Welcome to this masterclass. Today we're doing a complete deep dive into the armature winding of AC machines. Whether it's a power plant turbo alternator or a simple washing machine motor, the armature winding is the invisible backbone. We'll look at why we place these on the stator for better insulation and cooling, and how flux versus EMF induction drives performance. Let's speak the language of winding design. We start with the conductor, the active length of wire in the slot. Two conductors form a turn, and turns connected in series form a coil. The most critical metric is the coil span or pitch, the distance between the two sides of a coil. When this span equals the pole pitch, it's 180 degrees electrical, a full pitch. Why do we use short pitching? By making the coil span less than the pole pitch, we save copper and, more importantly, eliminate unwanted harmonics. This ensures the induced EMF is as close to a pure sine wave as possible, which is essential for efficiency and reducing noise. Classification by layers is our next step. Single-layer windings are common in small fractional kilowatt motors for their simplicity. However, the industry standard is the double-layer winding. With two coil sides per slot, one top and one bottom, designers have the flexibility needed for short pitching and sophisticated winding patterns. The geometry of the connection defines the application. Lap winding, where coils lap back over each other, is the go-to for high current and low voltage. In contrast, wave winding progresses forward around the armature in a wave-like shape, making it ideal for high-voltage, low-current machines. Finally, we have arrangement-based types. Concentric or basket windings are common in induction motors for their excellent cooling air gaps. Then there's mush winding, named for how the coil ends overlap in a disorganized fashion, frequently found in small, cost-effective AC motors, where ease of manufacturing is key. In modern design, we often use fractional slot windings to reduce cogging torque. Everything comes down to the winding factor key W. Understanding these principles is the first step in advanced machine design. If this deep dive helped your engineering journey, subscribe for more industrial chemistry and electrical teardowns. See you in the next breakdown.